All right, guys, today we are looking at partitioning a segment. One of the things that I want to kind of bring back here is we were talking about midpoints. So I had a segment where I would have a midpoint, and these pieces here were equal. So what that meant is my segment was divided into two equal pieces here and here. So my segment was divided into a ratio of 1 to 1 by that midpoint. Okay, so because I had an equal piece here and an equal piece here, I had a ratio of 1 to 1 because there was one piece on one side, one piece on the other side, and they were both the exact same length. So now what we're going to look at today is how we can find out where a point is located is if it's not in that 1-to-1 ratio, if it's not exactly in the middle. So for example, like this problem here, we're trying to find a point that is in a 2-to-1 ratio from A to B. So what that means is that we're going to have equal pieces. We're going to take segment AB and we're going to divide it into equal pieces. So what I want to know is on my point, I'm going to have two pieces on one side of the point, one piece on the other side of the point that I'm looking for. So that means that if I have two on one side, one on the other, I have a total of 3 different pieces, 3 different parts to my segment, okay? So that's your just 2 plus 1, you have a total of 3 parts. I want, if I'm doing a ratio from A to B, this is A, this is B, because we say this is 2 to 1, so A to B, so what comes first goes together, what comes second goes together, okay? So what we're looking at is I want 2 equal parts to be on the A side of the segment, so over somewhere on this side, and I want 1 equal part to be over on the B side of the segment. So what I'm trying to figure out is where exactly that point is. So the first thing that I want to do is I want to look to see exactly how long my segment is. So I go from 0 to 6, so AB has a length of 6. Now, I want to know if I have 3 equal parts. I am taking the segment and dividing it into 3 equal parts. So I'm going to take 6 and divide it by 3 to get that each piece is going to have a length of 2. So what I'm going to do is every 2 units, I'm going to draw a little dotted line so that I know now I have 1 part here, 1 part here, and 1 part here. And all 3 parts again are equal. So now I want 2 parts on the side with A because that's my ratio with 2. So I'm going to go 1 part, 2 part. So right here is the point that I'm looking for. So I have 2 equal parts over here and 1 part over here. So I have a ratio of 2 to 1. If you have any questions, write those down on those printed notes. So I want you to go ahead and try this one on your own. So go ahead and pause your video now. Okay, so there are a couple of different things about this one from the previous one. Number one, yes, the ratio is different. So instead of having a total of 3 parts, we have a total of 4 parts. So I'm taking my same segment that had a length of 6 and now dividing it into 4 equal parts. So that means that each piece, each part, is going to have a length of 1.5 units. All right. Then another thing that is different is that with this problem, instead of going from A to B like the last one, we are going from B to A. That means that I want 3 parts on my B side over here and 1 part on my A side. So I'm going to go from B 1, 2, 3 slices, or 3 parts, okay, to get that the point that I'm looking for is at 1.5. Okay, so I have 1 part on my A side, 3 parts on my B side. Again, please write down any questions that you have. Now, what we're going to look at here is what happens when we have our segment on a coordinate plane, not just a number line. Okay, there are 2 ways that I'm going to show you how to do this. I'm going to show you how to do it strictly with a graph, and I'm going to show you how to do it algebraically. When you are doing your homework, you may choose how you want to do it. However, please know that it is going to be, or you're only going to be able to do it graphically if you have nice numbers, whether they are whole numbers or halves. Maybe sometimes thirds are okay if you can kind of figure out which side you're on. But in general, stick with whole numbers and halves, and you can do it graphically without a problem. If you have nasty ratios like, 4/9 or 11/13, whatever the case may be, like you have really odd, wonky numbers here, then you're going to want to do it algebraically. So I'm going to show you how to do it both ways. Again, we're going to start with it graphically. The next thing that I want you to realize is when they give you a graph, they're only going to give you this blue line. They're not going to give you these red dotted lines. So if you're doing your problem graphically, one of the first things that you're going to want to do is go ahead and draw in those red dotted lines so that you can see your change horizontally and your change vertically. Okay, so your run and your rise. We are going to do this exactly the same way that we did it on the last problem. Okay, the last problem, the first thing we did was find out how long the segment was. So we're going to do the same thing. From here to here, I can count. I see that there's -8 on this side and +8 on this side. So I have a total of 16, or you can just count it, whatever you want to do. Okay. Then I'm going to look and see how many parts am I dividing that segment into. If I have a ratio of 3 to 1, that's 3 parts on one side, 1 part on the other. So I have a total of 4 parts. Okay, so if I'm taking a segment with a length of 16 and I am dividing it into 4 equal parts, that means that each part is going to have a length of 4. So 1, 2, 3, 4. Go here and here and here. Okay, so I have now divided the horizontal component of this into 4 equal parts. So the next thing that I'm going to look at is, okay, look at my ratio. It's from A to B. So that means that this is A and this is B. So I want 3 parts from part A. So what I'm going to do is go from A and go 1, 2, 3 parts over. And I am going to extend this dotted line all the way up to the top. Okay, so that's the horizontal component. I am going to repeat that for the vertical component. Again, the first thing that I'm going to do is find out how long my segment is. And that was kind of a wonky. Okay, so again, there's 5 above, 7 below, so I have a total of 12, or you can just count. Okay, again, I want to take this because I have 4 equal parts, so I'm going to take this segment of 12 and divide it into 4 equal pieces. So 12 divided by 4 is 3. So each piece is going to have a length of 3. Okay, so now we have divided this into 4 equal pieces. Again, from point A, which is going to be down here. Okay, B is at the top. I'm going 3 to 1. So I'm going to go from A and go 1, 2, 3. So that's this line here that I'm going to extend. So right here, and I didn't change colors. Okay, right here is going to be point P, which is at the point 4, 2. Okay, so that is how you do this problem graphically. Again, it works only when you have nice, pretty numbers. Okay, but there are times that our numbers are not very nice. So now we're going to go ahead and show you how exactly you are going to do that graphically. So it's going to be the same thing here. Okay, what we're going to do, the first thing that we want to do is find the length of the segment. When I am finding this segment, the change in X, the change in your horizontal distance, I am going to take the absolute value of your subtracted X's. So when I'm looking at that horizontal distance, it's going to be the absolute value of your X for A minus your X for B. So -8 minus 8. We use absolute value because I don't have a length of -16. I have a length of 16. Okay, so that's the same thing that we found here. So our lengths match. Okay, then we do the same thing for our y. We find that change in that vertical distance. So the next thing that I'm going to do is subtract my y values for my a and my b. And now I can switch the points if I want to at this point, and I'm going to just to point out something here. If I do 5 minus a negative 7, remember that is the same thing as saying 5 plus 7. So we have a length of 12. So again, matching up here. The next thing that I want to point out is where this fraction right here comes from. They go p is 3/4 of the way. Well, if I look here, I'm going 3 out of the 4 total pieces. So that is 3/4 of this length. So what I want to do is figure out exactly how long this distance is. How far am I traveling from point A? So the way that I do that is I'm going to look at my horizontal distance first. And I'm going to take 16 and I'm going to say, okay, what's 3/4 of 16? And when I multiply that, I'm going to get 12. I'm going to do the same thing with my y, and I'm going to say, okay, if I have 12 from my y distance, my y change, what is 3/4 of that? And that is 9. So that means that from point A, I need to move horizontally 12 units and vertically 9 units to get to where I want to be. So the way that this works is I am going from point A. So to find point P, I'm going to start by writing the coordinates of point A. So here's point A, -8, -7, and I'm plugging this in right here. Now the question is, I know that I need to be doing something with the 12 for my x value and the 9 for my y value. If I'm starting at A, I am moving to the right and up to get to my segment. So because I'm moving to the right, I am adding. Because I am moving up, I am adding. Those are both positive directions. So this point is going to be at the point 4, 2 when I simplify here, which is what we found graphically earlier. All right, questions on that? If you have them, please write them down. Okay, I am going to go ahead and pause this video now because I don't have enough time to do the next problem. So go ahead and tune in to part 2 once you have finished watching this video.